It's just a little bit higher. We are going to try to do the gallon stand reaction today. Hope it works. Doesn't always, but we're going to give it a shot. So I'm in the lab, and we're going to pour into this petri dish a solution of copper 2 chloride that's been acidified. That blue color, that just tells you that, well, I don't want to say it tells you, but the blue color is from the copper solution. All right, next we're going to just try to inject in some gallon stand. I've done a video on this if you want to check it out. We're going to try to use some used gallon stand. Gallon stand, it's an alloy of 3 different elements: gallium, indium, and tin. And I'm going to just get some of this gallon stand. It's right here, down here in the bottom corner. Might be able to see it's a little bit, not a little bit, it is a liquid. And I'm going to use this syringe to get some of the gallon stand into the syringe. You can see I'm pulling it up. Focus is a little problematic, sorry about that. And then we're going to try to inject this gallon stand into the fluid here. I don't think it's working. We'll work on it. We'll work on the effect a little bit. Let me get the lights off here first. That'll reduce some of the glare. And I'm going to try to fiddle with this. We can see it's a liquid, right? That's a liquid blob that's floating around. I want to say floating around. It's moving around in the petri dish. And I'm going to poke this a little bit, see if we can't get it to do its magic. And it doesn't seem to want to go. It does. It looks like mercury, and it's actually used as a mercury replacement in many applications because it's not as toxic as mercury. Not even close. You know, it's safe to hold in your hands. All right. Well, let's try again. Try a little bit more. It's a little tough to see here in the dark, but we're going to give it a shot. I'm getting a little bit more. It's called gallon stand. That's the name of the liquid metal alloy. It's a mixture of gallium, indium, and tin. Look at that. Isn't that cool? It's a really beautiful effect there going on with the lighting. I don't know if you can see it. Let's try to... What I'm hoping, though, let me try the other. I'll get some fresh stuff if this doesn't work. So I've used this gallon stand before. Hey, 777, thank you for the sub. I appreciate that. What we're looking at is a liquid metal alloy called gallon stand. Hey there, Aiden. How you doing? ADM man, I'm sorry. Let's see if this stuff works. What I'm hoping is that the copper in solution, the blue stuff, will react with the gallon stand and form copper nanoparticles on the surface of the gallon stand. And if that happens, we are going to see some really cool magic. I got just a little bit. Let me just inject some of this in here and see what it does. Just a little bit. Oh. There it goes. Oh, it wanted to go a little bit. There it goes, man. Starting to do a freaky little freak. Try to get a little more out. I wonder if this stuff is kind of solid. Pencil God. It is a liquid metal alloy called gallon stand. There we go. Come on, baby. Let's see what happens if we pop it in the other one. See if we can get it to do some action. No, it's struggling today. All right, I'll get some fresh stuff. So what'll happen is the copper in the solution, it reacts with the gallon stand, forms some copper nanoparticles on the surface. And when that happens, it changes the surface tension of the gallon stand, and that causes the gallon stand to spread out. I'm gonna, excuse me a second, I'm gonna go get a fresher gallon stand sample, and we'll try that one, okay? You can see there's a bunch of like gunk that's forming on the surface of this. Those are copper nanoparticles. If we get enough of those on the surface, we're going to see some interesting behavior happen on the gallon stand. We'll just check it out here. Okay, give me a second. I'll go get some fresher gallon stand. I apologize, it's a dud, but I wanted to do this live, and I just wanted to see what kind of stuff ends up looking like. You know, when I'm fiddling around in the lab trying to get things to work, it doesn't always work the way that I want it to. All right, so now I've got some fresh gallon stand, and I'm going to see if this is going to work a little better. So I'm drawing it up into this syringe. You can see the liquid metal going into the syringe. I know it's a little out of focus, but I'm going to go ahead and inject this in here and see if it's the gallon stand, or if it's it might be the, well, I guess it's the, it might be just the, oh, don't go over there. I don't want you going over there. It may just be the solution I need to make up fresh. I've been using this particular solution for quite some time. I'm wondering if that's what the issue is. Try a little more here, and I'm going to pop them together just the heck of it. It does look kind of cool. I mean, unfortunately it's not working the way that I want it to, but that happens sometimes. If you look closely, you can see there's some sort of structures that are forming on the surface of the liquid metal blob. Get away, I don't want you two to go together. Look at this down here. You can see there's a lot of action, some chemical action forming on the one on the bottom. So what's happening here is I have a liquid metal alloy called gallon stand. This is this thing in here that looks a little bit like mercury. And I've got it in a dish that's full of copper 2 ions. And there's a chemical reaction that forms. There's actually, you can see it down here, there's a little bit of copper metal nanoparticles that are forming on the surface down here. Yeah, there are some bubbles happening for sure. I see them too, right? I see them too. There's definitely something happening here. Let's go ahead and let them combine and see what happens. Whoop! Now it's all one big blob. Oh, that's cool. Looks a little bit like venom, doesn't it? Yeah, a little bit. Well, I know how to get this to do some action, so give me a second here and we'll give it a shot. What I'm going to do is I'm going to go get some copper crystals, and then I'll add that to the solution, and the gallon stand you'll just see. Just give me a second. This will work. All right, got my scooper. Let's get some copper chloride crystals. There we go. All right, I'm going to add some crystals of copper 2 chloride to this. So here are my, it's going to turn into a monster, huh? Maybe. How's the focus, by the way? Not so good, huh? My camera's bad too. Anyway, here's some crystals of copper 2 chloride. I'm going to pop them in here. And then I'm going to coax. There goes, baby. Come on, baby. Look at that. Tell me that ain't cool. Come on now. So what's happening is the liquid metal, it reacts with the copper ions, and that forms some copper nanoparticles on the surface. And those copper nano, thank you, Riz Lord. Those, those copper nanoparticles change the surface tension of the liquid metal. And when the surface tension changes, it actually lowers. And when, surface tension just describes how well a liquid spreads out. And so if the surface tension lowers, it indeed does look like venom. If the surface tension drops, that means that that liquid there is going to spread out easier. And because it spreads out, notice it spreads out into the crystals, and that makes the reaction happen even more. So here we go. I'm gonna. You notice here, over here. Those are the crystals. This is the gallon stand here. And if I get that gallon stand to touch those crystals, let me get it over here. Let's pop them together. There it goes, man. Come on, baby. Looks like doggone venom, doesn't it? It's like I'm making venom in my chemistry lab. It's not venom. It's just a chemical reaction that's happening on the surface. You'll notice it gets kind of black in color. And that chemical reaction on the surface changes the surface tension, which allows the gallon stand to spread out more. And that's what gives that very interesting effect. And, it's a very chaotic process, but it's interesting nonetheless. I'm going to go ahead and turn the lights on in the room and turn off this background light. And we'll see if we like that better. You all let me know. The room lights are on. And now my light box is off. Does that look a little better than before, or does that look worse? Let me know. The lighting, what do y'all think? Well, let's try this. Maybe we'll do a backlight. Does it get small enough to disappear? Well, this doesn't get small. This is the gallon stand liquid. If you look closely, you'll be able to see. I'm gonna get a little bit of light on it. That may help a little bit. If you look closely, you can actually see some of the copper nanoparticles on the surface. Kind of looks like I don't know, little growths on the surface of the gallon stand. You can see that. You see those little growths there, and you can also see some bubbles forming, which tells us there's a there's chemical reaction going on. I see a bunch of bubbles forming. I don't know what the identity of the gas is that's forming. I imagine it's hydrogen, but I'm not sure. It does look like a little, I don't know, what the heck does it look like? A little rock or something. It's kind of interesting. Okay, let's add a little bit more crystals of copper 2 chloride. So that'll get it to dance. At least I know I got that working. So I'm going to add just a few crystals here. So I want to get this thing dancing. So again, the gallon stand, that's that liquid blob that you see, that silvery liquid blob, that reacts with the copper ions, which I'm going to add here. It's already in solution. The blue is from the, this blue salt dissolved. This blue salt has copper 2 ions, and those copper 2 ions, they react with that liquid metal, and it changes the surface of the liquid metal. And it makes it so that the surface, the liquid blob can spread out more because it lowers the surface tension. I'm just going to put a few more crystals in here. And then I'm going to give this a little nudge. Here we go. Give that baby a little nudge. There we go, baby. Come on now. Isn't that cool? Isn't that awesome? So if you want to learn a little more about this, I've got a video on it. I've got a long form video and a short form video on this effect. You can learn about it a little more. And I also included a reference to the scientific literature that, if you're really interested in going in great detail, you can get a hold of that article. It's really cool though, ain't it? Flubber, huh? Flubber says agape. It did look like Pac-Man, Brennan, and actually one of my videos I say that. It's like a chemical Pac-Man. Thank you there, clowning around. If Pac-Man was a horror movie. I love it. What happens when you take it out? So what happens when you take it out is it, well here, let's do that, all right? So I'm gonna have to get another dish, so give me a second here. Thank you there, Carmen. I'm gonna get another dish so I can take the gallon stand out. Forgive me a second. So here is a second Petri dish that all kind of, here, let's put this one here. And let's stick this one here. All right. And then I'm going to use my syringe to try to get some of this into the syringe. Like I'm trapping it. Come on, baby. Let's see if I can get some of you out. Let's see if I don't know. Yeah, I think I'm pulling it in the syringe. Yeah, I'm getting some. Sure enough. Okay. You can see down in the bottom of the syringe, I have some of the liquid metal. Now I'm going to stick it over here on this side. Just get it out. There it goes. There is some gallon stand on this plate. There it is. Moving around, right? It looks like it's kind of stuck though, doesn't it? I mean, it adheres to the plate. And that's because if the solution that it's in is not acidified or highly alkaline, it tends to stick to the glass. But fortunately, there's enough acid on the surface that I think it's able to kind of move around. So there's some pure gallon stand there. There's a little bit I spilled on my... There we go. I got it up. It looks like mercury, but it's not. Will copper be sucked up in the syringe as well? Indeed, it will. Want to get? This is called gallon stand. Big lawn, it does look like mercury, but it's actually a mercury replacement called gallon stand. It's an alloy of 3 elements, gallium, indium, and tin. And those 3 elements, when you mix them together, they make a liquid. It's like 68% gallium, 20% indium, roughly 27, I think. It's hard to remember the exact numbers, and like 10% tin. Yes, I can hold it in my hands, Crystal. I've done that, but I prefer to just wear gloves. Hubert, thanks for the subscription. I appreciate that. Aslan, thank you for the hello. Thanks for reaching out and saying hi. And we're going to take, you can see there's like 3 different spots in the syringe where I've got the gallon stand out. Let's pop it over here. Pop it over here, get it out. There we go. And now what we're going to do, I want to show you this. You're going to love this. What copper salt is dissolved in the solution on the left? Hairgel. What is dissolved over here is copper 2 chloride. It's 1 molar. And it, in addition to 1 molar copper 2 chloride, 0.3 molar copper 2 chloride. And in addition to that, it's 1 molar in hydrochloric acid. So those are both in here. It's in a sense, it's more like liquid gallium because it contains more gallium. It's not poisonous to the skin. It is not heavier, more dense than mercury. It's about half as dense as mercury. So mercury's density is roughly 13 grams per milliliter. This is like 6.5. Hey, thanks there, Sam. Now what I'm going to do, just to show you, this is really cool. I'm going to add some crystals of copper 2 chloride to this solution over here. And you just watch what happens. You're not going to believe this. Thank you there, Sam. Moreno, what we're doing is we're messing around with a alloy called gallon stand. It's an alloy of gallium, indium, and tin. That's a liquid. Now I'm adding some crystals of copper 2 chloride. That's the same thing that's dissolved in the solution. And this causes a reaction on the surface that lowers the surface tension of the gallon stand and causes it to spread out. And it's like a spontaneous motion that occurs because, of course, this spreads out into the crystals that make it react. Blue Game, sure. I love me some Nile Red. I enjoy watching his experiments for sure. I tend to do things with a little bit more PPE than Nile Red. What if you out copper 2 chlorine in the dish without all the acid? I'm sorry, Monahat, I don't understand the question. Nice, Blue Games. Yeah, I get called like the discount version of Nile Red a lot. And I just tell people, you know what? The experiments he does, we chemistry teachers have been doing that since like before the 1970s, which is true. What if I add? Is this, it is, fellow, it is an alloy of gallium, indium, and tin. Yeah, I think it's science. It's Gallium. That's the trade name for this alloy. I'm gonna add some crystals of copper 2 chloride. Here we go. Just add a few there. In the other dish, what happens if you, there you go. Great suggestion. So let's do it in this one first so we can see what happens in our control. I added my crystals of copper 2 chloride, and you can see the gallon stand, you know, just preferentially goes towards it and does like some really freaky stuff. What's happening there is the gallon stand reacts with the copper 2 crystals, and when it does that, the surface tension of the gallon stand lowers, and that causes it to spread out. We might be getting to the point where this is going to do some goofiness, but maybe not quite yet. Maybe it needs to be acidified just a little bit. Let me try that. I'm going to add just a little bit of hydrochloric acid to that. Bear with me. Okay. It's going to add a drop of hydrochloric acid. I'm wondering if that's what's causing it not to be able to do its thing. Just add a drop here. I'm going to add a drop right on it just for the heck of it. No, maybe not. Looks like a bunch of little copper particles are growing on the surface, doesn't it? Mix that up just a little bit. Doesn't look like it wants to do anything right now. Let's try this. I'm going to suck this up. There's a bear with me? I don't understand the question. It does look like a jellyfish. What's on it? What's growing on it is some copper. So there's copper. There's a reaction where the copper in solution actually plates out on the liquid metal. And that's forming the, you know, sort of the coppery or black colored growths that you see. So you can see I'm sucking it up here into this syringe. I'm going to try to inject it back and see if we get action, but no, it doesn't look like it. So Monahan had a nice suggestion that I want to mess around with. He said, hey, or they said, hey, would the HCl react and make copper chloride dissolve? Probably a little bit. Here we go. So here's the, thank you there, Random, I appreciate that. So here's the gallon stand in a dish. It's got a little bit of the solution around it, but not much. And Monahan, I apologize, I know I'm not saying your name correctly, but I'm going to go ahead and they suggested that I put some crystals of copper 2 chloride in with this, which is a great suggestion. I've never tried this before. Let's see what happens. Let's see if it eats it. I'm gonna nudge it just a little bit. It looks like it wants to go towards it, doesn't it? I mean, I'm helping it, but there it goes. You can also see that brown stuff. That's probably some copper that's forming on the surface. Interesting. Yeah, it didn't seem to work as well as in the other solution. Thank you there, Tony. I appreciate that. Looks like it has a face. Looks like all sorts of stuff is going on. To me, it looks like Pac-Man. Let's pop this one into here, all right? Just pop it in there like this. Come on, baby. Drip in there. Boop. All right, it went into one huge mass. I think I need to make up a fresh solution for my next live and use fresh gallon stand to see if we can't get the action that I often see with this material. But it's still pretty interesting. It's still pretty fun to mess around with. I'm going to do the, let's do this one more time, all right? Get an aluminum can. Not going to do that, Yash. Where is gallon stand on the periodic table? It is element number 31, if memory serves me correctly. Let's see. Zinc. Let's see. Scandium, indium. Hold on. Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Yeah, gallium. It's number 31. no, gallium, that's correct. Gallium itself is not on the periodic table, but gallium is, and gallium is one of the components in gallium. There are 3 elements that are found in gallium. They are gallium, indium, and tin. And, oh, there we can see, like, it's doing some goofiness, man. But it's not doing it spontaneously, which is what I was hoping for. Still, it's got some interesting effects going on there. No, I'm not drinking this stuff. I'm not gonna do that. There we go. Thank you, Yash. Element 31 is gallium. Gallium is not on the periodic table. Hey, thanks there, Memming. Appreciate it. That's right, Monahead. Yep, thank you for helping out there. It looks like this doesn't want to go. I wonder if I just need to dissolve a bit more copper in there. Let's just try it. Let's just put a bunch of copper in here. It's green, Dwayne, because I've dissolved some copper. See this copper? That gets dissolved in the solution. And I'm going to try to get this, like, the concentration of the copper just a little bit higher by dissolving this in. It looks like my gallium is just kind of done. It's done reacting. It's not going to do its business anymore. But still, that was pretty fun for a while. Pretty fun for a while. So I'm going to try this on a live again sometime. I was just in the lab and I thought I'd... it's not on the periodic table base because it's not an element. It's actually a mixture of 3 different elements. Thank you there, Kitty Cat. Appreciate that. Thank you there, Ramen. So this alloy shows different properties from all the separate elements. Yeah, it does. So gallium at this temperature would actually be a solid. All of the 3 elements would be a solid, but when you get them together, they form this interesting liquid. And I think it's, you know, right now it's showing behavior of both liquid and solid at the same time, isn't it? Because you'll notice, like, look at when I, you know, it's like a putty right now, more than it is a liquid. So when I pop on it and it deforms, the deformation seems to persist, which is kind of interesting to see. You see that? Like it just, yeah, like the deformations are lasting. See if I can draw it out into a line here. This is interesting. I've not seen this effect with a gallium before. Isn't that cool? Pop it this way, pop it that way, pop it this way. It's like a little half liquid, half solid blob. Very, very weird. Very weird. I've not seen this effect before. Look at how that... So yeah, this is different than the regular gallium because, you know, this has reacted a lot. There's a lot of copper that's also now been engulfed into the liquid, and I'm sure that's changing the properties of the gallium. Can I put ammonium hydroxide and hydrochloric acid? Sure, you could do that. Yep, you could do that. Well, folks, I think that's going to be it for today. I'm going to call it a day. It's an alloy called gallium that's been kind of used a little too much. That's why it's looking like it's like a metal putty. Hey, thank you there, Angie. I appreciate that. Take it out? All right, Robert, we'll take it out and we'll stick it over here. Let's do it. Let's do it. I'm not making uranium. All right. Oh, let me let you see what I'm doing here. I'm trying to remove it. See, I'm sucking it into this syringe because it is a liquid, but it's more like a putty now than a liquid, which is kind of weird to see. You can see it's getting smaller because I'm sucking it into the syringe. And now I'm just going to place it over here into this. Oh my God. That thing was like almost self-supporting in the air. Now I'm going to go ahead and get a little more out. It is like I've made a putty out of it. What the heck, man? Get a little more out. Let's put this in the dry dish and see if I can make that gallium tower, that gallon stand tower. Here we go. A little bit, man. Look at that. It's like a metallic tower. It's cool. There it is. Oh, it's sinking. Yeah, man, that's kind of cool. I got to get the right angle for you to see what I'm seeing. Hold on a second here. See, it's like a little tower. It's like a pile of metal. It's a pile of metal putty. Weird, man. Just weird. I keep learning stuff about this, just like, you know, phenomenological things about it as I goof around with it. Oh, let me just show you what I'm doing over here. Sorry about that. So yeah, it's just making a pile of the gallon stand. Let me get the rest of this out. Yeah, again, the gallon stand, the liquid, it reacts with the copper ions, which are the, you know, the green colored stuff in here, and it forms copper metal on the surface of the gallon stand, and that copper metal ends up getting engulfed by the liquid, and I think that ends up changing the properties of the gallon stand. It's making it like a little more solid-like. It's like a putty. It's like a liquid putty. The used gallon stand is like a liquid putty. I like it though. I mean, it's interesting. All right, let's get the last little bit out. See if I can suck it all into my syringe. There we go. Pop it into this plate. Is that what Wolverine would look like melted down? I loved it, man. I love it. Thank you there, Monahat. I appreciate it. All right, Kitty. Thanks for hanging out. Blue Game says touch it. Sure, okay, here we go. I got my gloves on. I could touch it anyway, but here we go. Over here. Let's see if it sticks. It's probably going to stick to my gloves. Actually, it didn't. Look at that. It did not stick. Yeah. I think that's right, Monahat. I think copper nanoparticles are, in my opinion, I think they're getting engulfed into the liquid, and that's changing the properties of the liquid metal, would be my guess. You're welcome, Blue Games. Science says, metal putty. Turbo, I am finishing up some experiments with gallon stand. The gallon stand is usually liquid, but after the experiment, for a longer period of time, it looks like the liquid changes more into a putty. And so I'm trying to remove the liquid metal from the experimental dish where it was reacting with copper ions. That's the blue colored solution. And then I'm sticking it over here in this dry container over here for cleanup. But yeah, it is behaving like a putty. Memming Slim, in a sense, you know, I've not eaten technetium, but I have had it injected into my body. They use it as a, you know, a medical tracer. So that you know, I've had different medical tests that have required me to be injected with technetium. Thank you there, Anvi. Well, Anvi, I post about one short video a week. So I'm always doing different experiments. Most of them are pretty simple, but some of them are a little more technical, like this one. What's the metal you can chew? I think that's indium. Correct me if I'm wrong, but I think that's indium. You all have access to the internet. You can tell me if I'm remembering that wrong. I think it is indium, though. I'm having a little trouble getting that last piece out, but that's okay. Now this is now like a metallic putty. I want to play with this just a bit. What is technetium, Anvi? It is a element that has atomic number 43. It is radioactive, which means it decomposes into other materials. Um, and its half-life, so the amount of time that it lasts is short relative to the age of the Earth and the universe, which is why it's not naturally found on Earth. However, it is produced in supernova explosions, and so we can see signatures. Technetium gives off a certain kind of gamma ray, and we can detect those gamma rays, in supernova explosions, which tells us that the technetium is produced during the supernova explosion. It just decays away too quickly for it to, last. There's my metallic putty. It's very cool. My metallic putty, it was started as gallon stand, but then there's a lot of copper that's been, oh, look at that. There's like a donut now. You see that? It's like a donut hole. Very cool. Bill Nye the crafting guy. Come on, man. That's funny. Yeah, that's an interesting effect I've got going on there. It's like, I don't know, man. It's interesting, though. I don't know, Route. I do not know. I would too, Angie. I would too. Well, hey, folks, I'm going to clean up. Pie-ish, I don't know what that means. Someone maybe explain what that means to me. I'm an old guy. I'm not up on the current slang. No, Anvi, I'm not a full-time YouTuber. I'm a full-time teacher. It's not mercury. It is, it's gallon stand that's been, what's the word I want to use? Perverted a little bit with some copper. All right, folks, I'm going to take off. I'm going to clean up. I got some other things I got to do today in my real job. So thanks for hanging out and checking out the beauty of science with me, all right? And, consider subscribing. I do lives. Usually my lives are Friday evenings. And, I do different experiments. So thanks for hanging out, and thanks for commenting and liking and subscribing if you do those kinds of things. And we'll be seeing you around. All right, folks, so long.